An inverse is simply going to be something that undoes something else. Now, before we can talk about inverses, I need to talk about one-to-one. Okay, so the concept of one-to-one. So this part was on your video. One-to-one, if a function is one-to-one, it's got to pass the horizontal line test. Was there an embedded question right there? Like, what is this a whole lot like? Yeah, so what's the answer to the embedded question? And what does the vertical line test for? Exactly. So if I want to know if it's a function, I run the vertical line test. If I want to know if it's one-to-one, I run the horizontal line test. A geeky way to talk about this, and I walked through this in the video, but a geeky way to walk through this is the fact that if your A value, if you have two X values that aren't equal to each other, then your Y values should also not equal each other. Okay, and I gave you an example of where this isn't true. I have two X values. My X values are definitely not equal to each other. One is not the same thing as -1. And yet my Y values are the same. And so we would say this is not one-to-one. And you say, well, Ms. Roberts, I can look at it and tell you it's not one-to-one. It doesn't pass the horizontal line test. And you're correct. Okay, so this, what's on the screen here, this is a geeky way of saying it doesn't pass the horizontal line test. Okay, so that's the concept of one-to-one. So let's just take a minute here and let's figure out whether each of these functions is one-to-one. Now, the majority of them, we're going to be able to think back to parents. Okay, think about what it looks like. Just think about what it looks like. So example 1, if I were to graph example 1, what would it look like? It's a line. So does the line pass the horizontal line test? Yeah, it does, unless it's a horizontal line, right? And in that case, what does a horizontal line equation look like? That's vertical. Y equals the number. It's a good thing to review that because that's going to be on your test on Thursday. So I know it's a line. It's not a horizontal line. So yes, it's one-to-one. What does example 2 look like if you graphed it? Yeah, it's a parabola. This is one of your parents. It's flipped over the x-axis. And so does it pass the horizontal line test? Nope. Let's skip number 3. That one's weird. Let's go to number 4. Yes. How about number 5? No, why not? It's a parabola. How about number 6? Why? She said yes. It's a line, but it's a curve. What does this guy look like? What does number 6 look like? Yeah, it's my reciprocal parent. Remember we graph him, the parent we graph in the first and third quadrants? Okay, so that's the reciprocal parent. And so, yes, it's one-to-one. What if it was the reciprocal square parent? What if I took this guy and put it in parentheses and I put a square on bottom?
It wouldn't be one-to-one.
Yeah, it would not be one-to-one. All right, so just keep that in mind. I'll erase that, but yes, it's one-to-one. Okay, now the one that we skipped. This is not one of our parents. Yes, we have a square root parent, but our square root parent doesn't have a square inside of it. Okay, so this is not one of the parents we've ever worked with. So when you're being asked about one-to-one and you're like, I don't know what it looks like, well, graph it. If we don't know what it looks like, put it in the calculator. So go ahead, put it in the calculator. What'd you say, Rebecca?
No.
No, it's not 1-to-1. Rebecca, can you describe to me what the graph looks like?
It's like a fat parabola that stops at the x-axis.
Yeah, it looks like a fat parabola that stops at the x-axis. So do this. You probably used a standard window, which is just fine. Go to the middle button, go to zoom. See how number 5 says square? What that means is it's going to take your X units and make them the exact same size as your Y units. Like right now, if you use a standard screen, you've got 20 units going this way and 20 units going this way, but this one's longer than this one. Okay, so if you go to zoom 5, I call it square it up because that means it's going to make equal left and right and up and down. So how would you describe that graph now? Yeah, it's actually a semicircle. So we have, let's see, what is it? X and Y axis, we got 10 and 10, right? Am I correct on that?
Yeah. One of my sides goes down like a little lower. It doesn't come all the way to the x-axis.
So it actually does, Rebecca. Which calculator do you have?
TI 84 plus C Silver Edition.
Not a color screen.
Yeah, it has a color screen.
It has a color screen. Interesting. Yeah. And it doesn't go all the way up to the x-axis?
No.
Hang on, stay right there. Huh. Interesting. It should. Do yours go all the way up to the x-axis? Your calculator's dead. You better get batteries before Thursday. But your two, Sierra and Devin, yours? Okay. Yeah, interesting. Usually, Rebecca, it's your calculator who has all the fancy bells and whistles, and the ones that are in the classroom are the ones that kind of, do you have two? It's what?
This is the lid on the bottom.
Right, but what's in the pink? Oh, gotcha. I thought that was a calculator case. Because my 84 plus C has a calculator case just exactly like that in red. So I thought that was another calculator. Okay, anyway. Blah, blah, blah. Yeah, I don't know how to answer your question, Rebecca. I have no idea. But since the question is it 1-to-1 or not, we can easily answer that. No, it's not 1-to-1. Okay, so then you had some interesting facts. Can you hang on to these facts and have them readily available? Because I'm going to keep asking you some questions, and they're going to go back to these 5 interesting facts over and over and over and over and over again. All right, so I'm going to skip that. Well, I will say this. Did you guys have any questions from that particular part of the video? No questions? Okay, so then let's jump into example number 7. And example 7 says to show that function f and function g are I'll get this, I promise, are inverses of each other. And it says that you should be using fact number 3. So what does fact number 3 say?
If two functions are inverses of each other, then the composite of g of x and g of h.
Okay, so you don't know this, but you had this on your very first test, but I didn't tell you it had anything to do with inverses. So you remember we talked about composition on the very first test, and there was one question on the first test that I gave you 2 functions, and I said part A, find f of g, part B, find g of f. And what happened was, if you did that correctly, both of those, when you found the composition, you got the value of x. So this goes back to interesting fact number 3. If my functions are inverses of each other, by the way, go to interesting fact number 1. What's a way to describe inverses?
They undo each other.
Yeah, they undo each other. So these are 2, just like our little thing at our activity at the beginning, where we undid somebody's process of thought, same concept. These are two functions that undo each other. So we're going to show that. Now we do have to show both directions. Okay, so this is a good time to review something that we learned back in chapter 2. So remember in chapter 2, we found f of g of x. Now that's not the way I wrote it in your interesting facts, but if you remember back to chapter 2, this was the way to write it that was easier to understand because it showed the order of operations. Okay. So if I'm looking at this, what do I begin with according to the order of ops? I've got to start with g of x. Do you know what g of x is? Yeah, it was told. So we're going to take out g of x. We're going to substitute, replace with what it equals. So keep the f there because you haven't done anything with it yet. And then replace g of x with x minus 3 all over 4. Now, again, I'm going to take you back to chapter 2 in your mind. Do you remember how I read that statement? F of, yeah, I called it F of ugly, okay? So let's go up here to the F statement. If I have F of ugly, I'm not going to say X, I'm going to say ugly. F of ugly is 4 times, what did I call that guy? Ugly plus 3. Okay, so we've got f of ugly is 4 times my ugly. I'll just leave an open set of parentheses there. There's my 4 times my ugly plus my 3. And where do I get that ugly from? Yeah, that line right up above what I just wrote. So this is going to be filled in with my ugly, which was x minus 3 all over 4. Now, I know that the test is still a ways off for chapter 6, okay? But this is important. When I'm looking at the work for this, tell me what is it that I can do here to make things easier? The 4s will cancel. After I cancel the 4s, what then will happen? The 3s will zero each other out. Now, here's the thing. Did you notice that the directions said to show? If you just go and you just cancel all of those, I won't be able to see whether or not you canceled in the proper order, okay? So this is one of those things where when it says to show, you have to follow the order of operations by showing. So the first thing that's legally allowed to cancel is those 4s, and that's going to leave me with x minus 3 plus 3. And then I can zero out the 3s, leaving me with my x. Okay, so just make sure that you are showing in the proper order. Now, like I said, interesting fact number 3 doesn't just say to test f of g. What else does it say to test? G of f. Excuse me. All right, so g of f. All right, so where do we start this time? F of x. So I got g of my f of x is 4x plus 3. And then this is, we would say that, bless you, this is g of ugly. So let's go up here to our g. G of ugly is ugly minus 3, all divided by 4. So, bless you again, we've got ugly minus 3, all divided by 4. And that ugly is going to be the 4x plus 3. Now, in this case, what cancels first? Yeah, the 3s, leaving you with 4x over 4. And then that reduces to x. Now, guys, I know I'm supposed to end up with x. Interesting fact number 3 says I have to end up with x. So it's like, I'm giving you the answer. You just have to show me how to get there. Okay? So don't just say, well, Ms. Roberts, they both end up being x. And don't show me anything. Okay, so you know they're going to end up with X. You just have to show the work that says they're going to get there with X. I don't think I have this on a video if I remember correctly, but I did provide the work so that you can try it on your own and just see one that is a little bit uglier. All right, number 9. Is the following function one-to-one? And if it is, find the inverse. Okay, so let's talk about the first question. Is it one-to-one? Can you go back to the beginning of class today? Remember the embedded question that said, where else have you seen a test kind of like this? And you told me that it was where? Yeah, function in the vertical line test. Can you guys remember, how did we test for a function if all I had was a list of coordinates? Say it again, Sierra. Yeah, okay, so Sierra said it. I don't know if you heard her or not, Rebecca. But basically, if I'm testing a group of coordinates to see whether or not that group of coordinates is a function, I can't have X repeats. That was how I worded it back in chapter 1 and 2. No X repeats, okay? And no X repeats translates to it passes the vertical line test, okay? Well, what do you think is gonna be the same thing as the horizontal line test? Yeah, no Y repeats. Okay, so if I have no Y repeats, then it's going to be one-to-one. So take a look at example 9. Is this one-to-one? Yes, it is. All right, and then let's follow up. If yes, go find the inverse. Okay, now look at your interesting facts. I believe, I'm going on memory, I believe this is interesting fact number 4. Can somebody read me interesting fact number 4? Interesting. Okay, so if xy is on the original, then yx is on the inverse. Okay, and so basically what we're saying here is I can trade my values. It's like undoing my function. Okay, so then what would the inverse be? Now let's write it correctly first. Let's learn how to write it. If g of x is the original function, what interesting fact told me how to write it? It might have been number 1. How do we write inverse? Yeah, it looks like, okay, so Sierra, your words are wrong, but your thinking is right. To say f of -1 would be to say f of -1 like that. Literally, I'm plugging in -1 for the x, okay? So, it kind of looks like a power, doesn't it? It is not. That's a big deal, okay? So this is going to be G inverse is written, it looks like the power of -1. It is not the power of -1. Who decided to make that so confusing? I don't know, but that was long before I was in existence. And so, yeah, so just even on your calculator, you've got a little button that says x to the -1 power. That's not the same as this. That's not the same thing. It doesn't do the same thing. Okay, so just be aware of that. All right, so what is my new function then, according to interesting fact number 4? Okay. Okay. We can all take one here. 3215. Rebecca?
4220.
4220. Notice that I'm using the curly brackets because I'm making a list. Okay, so this is listing notation is what I'm using. All right. How do you find inverses? If I tell you, here's a function, go find the inverse, how do you do that? So here's a how-to. Keep it handy. All right, so, and I'll just direct you back to this as we work through the next example. So number 10, first of all, says to find the inverse. Okay, part A. So let's go find the inverse. What does step number 1 tell you to do in the tips? This is a 4-step list. So what does step number 1 tell you to do? Change f of x to y. Well, when you look at my function here, I already have a y. It wasn't written as f of x, so we're good with that. Okay. What does tip number 2 say to do? Somebody else?
Trade X and Y.
Trade the x and the y. Now, what interesting fact does that go back to? Number 4. Yeah, where my x's and my y's are going to become my y's and my x's. So we're going to have here, I'm just going to go down below the chart. X equals 4 times y minus 5. I'm just trading the x and the y. What does tip number 3 say to do? Yeah, solve for the new y. So let's go get y by itself. This is normal stuff. So how do I get that y by itself? What is it? Yep, add 5. So we got x plus 5 is equal to 4y. Can you go ahead and just tell me what to do? Divide by 4. So I'm going to go ahead and divide by 4. What does tip number 4 say? By the way, this is the tip that people usually forget to do and it costs them. So what does it say?
Change y to f inverse of x.
Yeah, f inverse of x. Now, here's the thing. Right this minute, the reason that this is not written properly, it's almost indicating that this y and this y are the same thing because they're the same letter. But they're not, okay? So you have to, because we found an inverse, you have to give it a new name. Now, it wasn't f of x to begin. Well, I guess I used f's there in my chart. So you can either write f inverse of x is equal to x plus 5 over 4. All right, so that's my inverse. Okay, these are undo buttons of each other. Now let's go look at part B. Graph the original. Okay, no problem. So when I graph the original, do you guys remember how to graph lines? What's that? You could go get x and y intercepts. That would be an option. Okay, do you remember slope intercept form? Y equals mx plus b? Yeah. So slope intercept form, y equals mx plus b, my b part was my y intercept. So where's my y intercept on the original equation? Yep, 1, 2, 3, 4, 5. And what's the slope on the original equation?
4.
Yeah, and usually slope is a fraction, a rise over run, so we would say it's 4 over 1. So we're going to rise, and this is from the the y-intercept. We're going to rise 4, and we're going to run to the right 1. So go up 4, 1, 2, 3, 4, run 1 to the right. I actually like to do this at least 2 or 3 times. So I'm going to do it again from that new point. 1, 2, 3, 4, run to the right 1. And one more time. 1, 2, 3, 4, run to the right 1. Now, what was the shape of my function? When you looked at the equation, what shape is that? It's a line. Okay, so no problem. Let's just connect the dots. All right, so that takes care of part A. That takes care of part B. Now part C, graph the inverse. Oh, Ms. Roberts, are you serious? That one doesn't look as nice to graph. Oh, but wait, there's an easier. What does interesting fact number 4 say?
So you change Y.
Yeah, okay, so take a look. Your original graph, you've got 1, 2, 3, you got 4 XYs. You got 4 coordinates. So take those 4 coordinates, trade the x and the y, draw a new coordinate. Isn't that a lot easier than having to worry about y equals mx plus b? Yeah, okay, so let's take the first coordinate. Let's starting down at the bottom. Trade the x and the y values. Where am I gonna draw a new coordinate?
On -5 on the x-axis.
Yeah. And then the next coordinate, think about what it was to start with. Trade the x and the y values. What coordinate will you draw? What's the new coordinate, the inverse coordinate?
-1, 1.
Good. Okay. And then the third coordinate. So let's get somebody else involved here. Rebecca did the first two very well. What's that? Think about what the coordinate is and what will I graph? 3, 2. Okay. That really is enough to graph, isn't it? My line. I could keep on counting if you really wanted to. Hey, what was interesting, fact number 5? About what? The y equals x line. They're symmetric about the y equals x line. Now you remember back in chapters 1 and 2, we talked about symmetry, and we had y-axis symmetry, we had x-axis symmetry, we had origin symmetry. Remember that was the one where we could turn it upside down, rotate it upside down. We've never had y equals x symmetry. But you notice on my picture, I have the y equals x line. It's in gray. It's a dashed line. And it's pretty easy to see that, yeah, my two lines, these are mirror images around that y equals x line. Okay, so that lines up with, no pun intended, interesting fact number 5. Okay, let's look at letter D. Letter D. So what's the domain of my purple line? What's the domain of the original? All real numbers, so this is going to be -infinity to positive infinity. And what's the range of my purple line?
Negative.
Also all real numbers. So this one's kind of boring. Okay. All right, can you go and look at interesting fact number 2? Interesting fact number 2. What does interesting fact number 2 say? It's the one I haven't talked about yet today.
The domain of f of x is the range of f inverse of x. And the range of f of x is the domain of f inverse of x.
Yeah, so this is cool to me because I don't even need my graph. Now this, like I said, this one's a boring one, okay? But I don't even need my graph to come up with domain and range for the inverses. All I have to say is, hey, if this is the domain of the original, it has to be the range of the inverse. So copy and paste. And if this guy is the range of the original, it's got to be the domain of the inverse. So it's got to go up here. Again, copy and paste. I don't even have to see the graph of the inverse to know this. Now, the nice thing is it's also a good way to check my work. Like if I graph wrong, and my domain and range for the inverse don't match up with what my new graph says, ooh, this is a way to check my work. It's a way to have a little bit of a red flag. All right, so number 11, find the inverse. I wanted to do number 11 because this one's a little more challenging. I did? Oh, well then did you guys have any questions from the video then? I'm not gonna work it out again if I worked it out in the video. Okay, now you will have something like this on your homework, and a lot of times my students ask me about this one in the homework. That's, I think, why I made a video, so that in case you can't get a hold of me, you've got a video that you can go back and you can take a look at. All right, so if I work that one out, then I'm not gonna work it out again. I'm not gonna waste your time. All right, so let's look at this next one. So for example 12, I've given you a function, and I've asked you to find f of 2. Guys, this is not chapter 6 material. Okay, this is chapter 1 material. As a review, chapter 1, it was a review in chapter 1. Okay, so how do I find f of 2? Yeah, so that's gonna be 2 cubed is equal to 8. Okay, no problem there. All right. What does inverse mean again? Interesting fact number 1. Undo buttons. Interesting fact number 4 also says what? That the x value becomes the y value and the y value becomes the x value. Okay, so notice this 2 here, this is my x value on the original, right? And the 8 is my y value on the original. We know even how to write a coordinate with that if we wanted to, right? That would be 2, 8. Okay, so now let's go backwards. If we're talking about the inverse, what is the inverse of 8? What is f inverse of 8? 2. Literally what we're saying here is what number cubed is 8? Instead of saying go cube 2 and get the 8 out, we're saying, well, what number if I cube it will give me an 8? That's the English version of that. How about number 14? What's f inverse of -8? What's the undo button of -8? -2. Again, that's kind of like the activity at the beginning of the class period where the first time you guys went forwards, you were doing an example like number 12. And the last time I made you go figure out, well, what did these people get for their original guess? And so that is the case here. All right, any questions? By the way, those are the easy ones. And a lot of times students miss those because they get to them and they're like, what does she want me to do here? That just seems too easy. Okay, so frequently these are the easy ones that people miss. Have you ever done that? Like you get to it and like, there's no way that she can be asking me this because that's just not, that's too easy. All right, number 15. Okay, take a look at what's graphed. Now I know you're looking at the blue part, but look at the directions. What does the direction say that I have graphed for you? F of x. We could say I've graphed the original. What have I not graphed? I haven't graphed the inverse. And yet, number 15, I'm asking you about the inverse. The inverse isn't on there. It isn't pictured. You can't see it. Okay. Now we could do that, but we're going to do that in number 18. So I'm not going to do that right now. Okay. So the idea is, I have a set of XYs, right? The original graph, these are XYs, but I'm trying to find YXs. That's what I'm trying to find. Okay. So you've got a Y value of 2. A Y value of 2. Okay, so go to your graph. Can you see where the Y value of 2 is? Okay, run across and find out what's the X value when the Y is 2. Which one? Let me say it. So let me say it again. Okay. When the Y value is 2, so remember this is the Y value. Normally f of x, we're looking at the x value first, right? Okay, but this is f inverse. So we're looking at the Y value of 2. Okay, the Y value of 2 is right here, right? Go find on the blue graph, go find what's the X value that corresponds with the Y value of 2. It's 3. Now, here's an even easier way to show that, okay? What is this coordinate right here? Can somebody just tell me what the coordinate is? 3, 2. So what would the coordinate be on the inverse graph? 2, 3. Can you see it? Does that make sense? Okay. Because you got to remember, I'm not looking at the inverse graph. I don't have the inverse graph drawn. Okay. All right. So then how about for number 16? What is an F inverse of -2? 0. That's this guy right here. So I'm looking at the y value of -2. My x value is 0. And then last but not least, f inverse of -4. -4. Okay. All right. I want you to take number 18. And I want you guys work together. Okay. I want you to graph the inverse. You're going to use interesting fact number 4. Okay. Graph the inverse on number 18. Talk through it. Now you've been graphing all alone. Talk about what you did. Okay, so Mary Alice is saying that she took the 3 points from the 3 previous questions, 15, 16, and 17.
And then you just add 1, which 2 0 would be 0 2.
Now, when you graph, does it match interesting fact number 5? What did interesting fact number 5 say? Symmetric about the y equals x line. Is your symmetric about the y equals x line? Yeah. So what I did was I said, hey, on that bottom corner, this is the coordinate -4, -4. Trade them. I got -4, -4, right? And then I took the first little corner here of 0, -2 and graphed -2, 0. And then 2, 0, I graphed 0, 2. And then 4, 4, trade, you get 4, 4. Okay? And so I connected my dots. And this is what I had. And yes, they do, they are symmetric about the y equals x line.